Hello, peoples.
Hello.
Welcome to Law of Sines, area of triangle with trig and Heron's formula.
Yep. So here we go. Law of Sines. This one is really cool, and if you had Mr. Lister for geometry, or Ms. Meller, you might have done Law of Sines, but you didn't do what's called the ambiguous case, and that is what makes this lesson fun.
You also did Heron's formula, so this is something you've seen before. Some of it.
Okay. Law of Sines.
Yay! Sine of A over little a equals sine of big B over little b equals sine of big C over little c. And you pick whichever two you want to use based on whatever things you have the matchy-matchies for. If you had me, I talked about matchy-matchies. And if you have the matching side and the matching angle, then you use sine of those two, and then one that you have one piece of and not the other piece.
And you can do it this way too, because let's remember, if you have a fraction 2/3 and that's equal to, I don't know, 4/6, isn't that true that 3/2 would be equal to 6/4? I mean, you can do reciprocals. So sometimes you might want to have your A on top because you're looking for A. And you don't want it on bottom, you want it on top because it's easier to do your math that way. Whatever. You can do the ratios either way. Now, why does this work? It is so cool to look at this. When you drop the perpendicular, okay, we're just going to call that height. And when we look at angle A, you can see that the sine of angle A is opposite over hypotenuse. That's this formula. And likewise, the sine of angle B is opposite over hypotenuse. That's this formula. And you can take both of these formulas and solve them for H. That means in this one, you're going to multiply both sides by B, and in this one, you're going to multiply both sides by A. Notice both of these quantities are equal to each other because since H has to equal H, then it turns out B sine A equals A sine B, and we can divide both sides by A and divide both sides by B, and look at this fabulous formula that we get. That's why it works. Much easier this one than the law of cosines, why the law of cosines works, huh?
Yeah. Okay, so here we are. We're going to solve the triangle if the angle A is 42, the angle B is 61, and C is 65. Well, right now we don't have any matchy-matchies, but in geometry you probably would have said, oh look, I could find out the last angle by just finding out what 180 minus the sum of the other two angles is. So that's how we would find C first. So that's what we're going to do. We're going to find C. We're going to have 61 plus 42, and that gives us 103. And then we're going to subtract 103 from 180, and you get 77. Okay, so that's angle C. Now you have a matchy-matchy. You have big angle C and little c, so that's going to be one of them that you use. And we're going to solve for A first. Why not? So we have sine of 77, or sine of A over little a equals sine of 70c over little c.
Yeah, show us the formula you're using. Then do the substitution so you can, it gives you a place to find a mistake.
Sine of big A, which is 42, over little a, which we don't know, equals sine of big C, which is 77, over little c, which we know is 65. And so that would be A times sine of 77 equals 65 times the sine of 42 degrees. Okay, make sure your calculators are in degree mode. So A equals 65 times the sine of 42 degrees divided by the sine of 77 degrees. And then we go ahead, plug it into our calculator, and we get A is approximately 638. So we want to be as accurate to 3 decimal places for our side lengths. Now, when we solve for B, we have two options. We could either use sine of big A over little a or sine of big C over little c. But if you use sine of big A over little a, you have a nasty approximated answer that you just got. That's not a good idea.
And let's remember too, from the very beginning, since we recognize this is not a right triangle, so we cannot use
Pythagorean theorem.
a squared plus b squared equals c squared. We can't do that.
So we're just going to use the law of
Let's
sines
do
again.
b and c. I like to use
The ones that are your given.
Yeah.
That's what I was saying.
Yeah.
If you use A, you're using an approximated value.
And you may have done it wrong. You may have hit a button wrong on your calculator. So
in order to decrease the number of errors that you make, it's best to use values that are either given or values that you got without much work at all.
is it okay to write the ratio like that?
Yes,
Why?
because of the reciprocal property of
Why would I want to do it like that this
the
time?
ratio. Well, we're solving for B. We could have done that the last time too. It didn't really make much of a difference.
Right, and you can see that we could actually take this and go B is equal to C times the sine of B over the sine of C. Now that's all ready for me to just substitute in right now.
So B equals 65 times the sine of 61 degrees over the sine of 77 degrees. And then we go ahead and plunk that into our calculator and we get B is approximately 58.346 degrees.
Now let's look at our information that we had.
Not
Notice,
degrees, a side length.
let's look at our angles. So we found C to be what, 77?
So that should
So
be
our smallest angle is A, and then our next angle is B, and then our next angle is C. So our angles should do like that, and do our sides do like that. We found side A to be 44-ish. We found side B to be 58-ish. And we know that side C is 65-ish. So did our inequalities hold?
Yes.
Yeah. And that's an important thing to check, okay? It just gives you a place that you can check careless errors. Now, I like to explain that you remember side angle was not a method. Well, first of all, if we reverse the letters, that's why it's not a method. So we can't solve that, but that's not really why it's not a method. Here's why it's not a method. If you happen to have an angle and the side adjacent and the side opposite, so I have the order of an angle and a side, congruent to, except I don't want it to be this angle, I lied about that. I'm going to make it this angle here, all right? So if my angle A over here is congruent to this angle A, and my side BC here, oopsie, dropped the pen, and my side BC here is congruent to this side BC here, and my side AB here is congruent to my side AB here. Do you notice that this side right here is like a swinging door? Okay? And there are certain conditions where when you have an acute angle given and the side adjacent to that angle, the one I've marked in red, and the side opposite that angle, this is the one we've marked in green, if those are congruent, there are certain conditions where this side, this bold one, could actually be a swinging door and give you two totally different triangles. And as you can see, those are not congruent. Our angle A is congruent to angle A, oopsie, congruent. Our side AB is congruent to side AB. It's congruent. And side BC, isn't it? It's been so long. Yeah, and side BC is congruent to, side BC. Notice that I have two sides congruent, and the non-included angle, and look at that. The triangles are definitely not congruent.
However, angle C is not congruent to angle C on this one.
Yeah. All right? So you can see, therefore, triangle ABC on the left is clearly not congruent to triangle ABC on the right. Okay, probably should have given those different names. Whatever. The point is, this is what gives us what's called the ambiguous case. So we actually have, this happens, notice that my angle A was acute. So we have a problem when the given angle that we know is acute, and then the other two sides, there's a relationship between the other two sides. Okay? Notice that if I drop a perpendicular here, do you see that with my perpendicular, which we would know to be the altitude, do you see that this black side, this heavy black side here, is longer than the altitude would be? Okay? And now that thing that we worked out a couple of problems ago, this right here, this why does it work? These relationships right here are going to be really important because this is what tells you right here about that altitude. And we're getting ready to look at something called B sine A. And we need to recognize that it relates to the altitude that could be drawn. All right, so here we go. Oops, and before we do that, you're going to work this problem. Okay?
1 and 9.
Okay. Now, so that slide should have been, the ET problem should have been before we got to this, so sorry about that. All right, so what we have is two conditions here. We have one condition where if our angle is acute and the side opposite the angle is smaller than the side adjacent, that is the thing we just drew. When we check this B sine A, I want to look and see how is the side opposite the angle we know related to B times the sine of angle A. Remember that back there in that problem that we just kind of looked at, if I drop my altitude, this is the height, and B and the sine of A, remember that the sine of angle A is the opposite over the hypotenuse, so B sine A is the same length as that height or the altitude that we could draw. And it turns out that if the side opposite your angle is bigger than B sine A, which is what would be the altitude, then you're going to get two solutions. Okay? If A is equal to B sine A, again, B sine A is the altitude, then you have one triangle. Why? It's a right triangle. Okay? Because that thing that was dropped from C is actually perpendicular. And then if A, which is supposed to be the altitude, is less than B sine A, you don't have a triangle at all. Notice, this is not even connecting. Okay? So our big thing to look for is this one right here. Okay? Acute, the side opposite smaller than the side adjacent, and the side opposite bigger than what would have been the height, B sine A. Okay? Now another thing you can have is angle A acute and the side opposite it greater than or equal to the side adjacent. If that happens, notice this side right here, side A, there's no way that this thing can swing and make another triangle. Okay, if we go back to this one right here, notice this side A can swing, make a swinging door, and be right there. Okay, this kind of, just imagine a door on a hinge. This can swing and make this, and that's why those two triangles don't work. But if we have this situation, this side A here cannot possibly swing over here and make another triangle. Okay? The other case that we have is if the given angle is obtuse. Obtuse, of course, means greater than 90 degrees. If the angle is obtuse, and this doesn't the side opposite, if the angle is obtuse, doesn't the side opposite have to be the biggest side?
Yes.
So if the side opposite, not the biggest side, side opposite, obtuse angle, not the biggest side. So if you have that situation, then you have no triangle. Okay? But if you have an obtuse angle and the side opposite is the biggest side, you only have one possible triangle. So our really hard situation is when the given angle is acute, the side opposite the given angle is smaller than the side adjacent to the given angle, and the relationship is such that you can get a swinging door. Okay? Here we go. So we're going to determine the number of solutions. Okay, so the first thing we're looking for is this. Let's start with what we know.
A is acute.
Okay, so we have, when you see that the angle given is acute, that means it might be a special problem and you are going to have to look at that situation possibly. What's the next thing? A
is smaller than B.
When you have this situation, you must do that relationship. Okay, so now we're going to figure that out. What is B sine A?
B sine A is 30 times the sine of 52, which equals 23.6.
Can't write, that's what I can't do. Okay,
So that means that A, which is 19, is smaller than B sine A, which is 23.6.
So what does that mean?
So that means there's no solution.
Okay, again, go back to your list. This is stuff you have to know, and it's a lot of material. What we had was, we had to check B sine A, and our A was less than B sine A, so we have this kind of picture happening. We have no triangle. Okay? All right.
Okay, so let's look. Angle C is obtuse.
Oh, we like obtuses. That means you either have one or you don't. Okay?
So it says that C is bigger than B.
And shouldn't side C be larger, the largest side in the triangle?
So this is a triangle, one solution.
Okay.
All right, so this one we have angle A is 40 degrees, which is an acute angle, so,
Uh-oh. My radar is up. My radar is up.
It says that A is 19 and B is 20, so A is smaller than B.
Oh, no. That means we have to do this checking.
Okay, so,
Now, by the way, when you get to your homework problems, you know, it may not be angle A you're given. It may be angle C you're given. And then you would have to look at side C less than the other one. So you have to actually translate, you know, all the different letters in the right order. Okay.
Okay, so, you're comparing the matchy-matchies, by the way.
The matchy-match. Yeah, there you go.
So, we've got B sine A is 20 times the sine of 40 degrees, which is 12.9. And A is 19, so 19 is bigger than 12.9, so that means we have two solutions.
What does two solutions mean?
Well, you got the
It's
ambiguous.
two triangles. This is the ambiguous case. Okay.
So,
All right. Now
we're going to do, angle A is obtuse. Woohoo! But A is not bigger than B. A is smaller than B. That means there's no solution. Okay.
Now we get to the absolutely horrible thing that this is a long problem. Here we go. Let's look at what we have. Angle A is acute, okay? And we have side A, the side opposite angle A is less than the side adjacent to it. So that means we have 0, 1, or 2 solutions, and we have to look at the relationship between A and B sine A. We want to know what that is, okay? So we're going to find A and B sine A. So it turns out that when I do B sine A, this is going to be 21 times the sine of 27, which is about 9.5. And so A is bigger than B sine A. Okay, if A is bigger, we have the swinging door. So we have two solutions. Okay?
Okay.
All right. I'm going to do this. There are 2 slides here, so we're going to do this set and go through that and then do one triangle and do the other. Okay? All right. All right.
So first we're going to use the stuff that we know, the matchy-matchies. Sine A over little a equals sine of big B over little b.
And why do you think we put the angles on top?
because I'm looking for the angle B.
Cool. Okay.
So we've got sine of 27 over 15 equals the sine of big B over 21. So the sine of big B equals 21 sine of 27 degrees over 15. So sine of big B equals approximately 0.6356. ... We don't know.
Hey, that's a positive value. Which quadrant is the calculator going to give me? Because
First
remember,
quadrant.
we have our restrictions now.
Yeah, first quadrant. So the
Okay.
angle B is approximately 39 degrees.
Okay, it's the angle whose sine is this. This is what we're going to enter in our calculator.
We're going to use the stored values.
And we're going to use the stored value. And remember that your restriction for sine is between negative pi over 2 and pi over 2. And that is the answers that are going to come up on the calculator. And remember that pi over 2 is 1.57. So we expect an answer between 0 and 1.5. Oh, no. 0 and 90 degrees. We're in degrees right now. So what do we get? B is what?
39 degrees.
39 degrees. Okay, that does give us a quadrant 1. But you know what? What is it that we did? We just did on the test that we would find if we knew that there is another quadrant where the sign is positive. Okay? We have something here. And where is the other one?
In quadrant 2.
And how do we find that one? Well, here.
Pi minus, or 180 minus.
Yeah, there is our 39 degree angle. And our other one, this one, we find by 180 minus 39. Your 39 is that reference angle there, and your 180 minus 39 gives us that. So B could be 39, or B could be what?
141.
141. And this is where we get two different triangles. So we're going to solve this with first triangle, okay? So triangle 1 has angle B to be 39 degrees. And we're going to solve everything with angle B being 39, and then we'll do the, right?
So if angle A is 27 and angle B is 39, then that tells us that angle C is 180 minus the sum of those two, which equals 114.
That means C in this case is our biggest angle, so side C has to be the biggest side. Side C has to be biggest. Okay?
Okay, so so C over sine of big C, little c over the sine of big C equals little a over the sine of big A, since we know what A and big A are.
There you go. And notice that Ms. Miller set this up nicely
Whoa,
with,
that should be a sine of big C.
oh, sine of big C. I wrote it wrong. She said it right. But she set it up with the letters first so that we are sure to substitute properly. Okay.
So I'm going to go ahead and solve. C equals A sine of big C divided by sine of big A. So we're going to just plug in C equals 15 times the sine of 114 over the sine of 27. Okay,
All right. So what do we get?
so we get C is approximately 30.184.
Now we have two things to check here, right? One of the things that you learned in geometry is, so our side C has to be the biggest, and A is 15 and B is 21 and C is 31.4. So it's true that A is less than B is less than C. A is 15, B is 21, and C is 30-ish. So whatever, that's close enough. But remember, the other thing you learned in geometry is that the sum of two sides has to always be bigger than the third side. So 15 plus 21 is 36, and 36 is bigger than 30, so we're good there. And we already know that this is the biggest side, 30, so of course 30 plus 21 is bigger than 15, and 30 plus 15 is bigger than 21. You got to do all of that checking. Now that's just with this triangle, right? So what we have is, if this is true, then side C is, what did you tell me,
30.184.
And there is the first triangle. But we have another possibility, and that is with this. So we're going to do that on the next slide. Okay? Okay, well, I thought we were going to do it on the next slide. I thought I had it. I was just going to get a new page. Here we go.
Just hit it again. Okay, so triangle 2. We know that angle A is 27 degrees. And we know that
What were the other two sides?
A is 15. Angle B is 141. Side B is 21. And angle C is, well, we have to find angle C. 27 plus 141 is 168, so 180 minus 168 is 12. So angle C is 12. So
that makes this the smallest angle. Now, okay, so when we did that swinging door, we now have the smallest angle, so now C is going to be the smallest side. Okay?
Okay, so we know that we're going to use the angle A and side A again. So we have little a over sine of big A equals C over sine of big C. So C equals...
Oh, you're right. Thank you.
C equals A times the sine of big C over the sine of big A. So we've got C equals 15 times the sine of 12 degrees over the sine of 27 degrees. Which, when you plunk that into your calculator, you get C is approximately 6.869.
Now, we said C needed to be the smallest side, and it is.
So yay. Okay, so there's our answer.
So we have 6.869, which is less than 15, which is less than 21. Notice that B is our biggest angle, and so B had to be our biggest side, and it is. C is our smallest angle, and now we do the other checking. The checking is side C plus side A bigger than B?
Bigger than 21, yes.
Okay, we're good. All right, we already know this is the longest side, so 21 plus any of the other two sides is going to be greater, so we're good that way.
Okay, next step. Go to 10-2 and work number 19.
19 is going to clearly be one that has two
Ambiguous
triangles. It's the ambiguous case. Here's a really cool thing with geometry. With trig is you can find areas of triangles without knowing the altitude, right? Remember that we've had the altitude. This uses, what does it use? Two sides and the included angle? Before, you had to know I can't spell and talk.
1/2 times the base times the height.
Yeah,
and we know that the height is actually the B sine A, right? So when we're looking for the area here, we've got 1/2 times the bottom part, which would be one of the adjacent sides, times the sine of the angle times the other side. Okay, so it's the two sides and their included angle. So here we go. In angle ABC, we know that angle C is 49 degrees. We know that A is 16 centimeters, and we know that B is 25 centimeters.
So we're going to draw our triangle and label it. So notice this part of the problem, you actually had to draw the triangle. 16, 25, and we're going to label that C.
Okay, we just need to find the area, and the area is going to be...
So we're going to use K for area just because our A gets confused with the angle A. So.
All right, that's going to be one of the sides, so we'll just call it 1/2 times one of the little sides, which is 25.
Notice it's the two sides that make up the angle.
Yes.
Okay.
So 25 times...
I'm going to write 16 first. Why?
You can take half of 16.
Yeah. Now, of course, I'm lazy and would do this on my calculator, but at least I can do, if I didn't have a calculator available and I had to give some kind of answer that was as far as you could go without a calculator.
Well, you would do 400. No, 200.
200, right? Yeah.
200 sine of 49. And that means K is approximately 151 centimeters squared.
Ah.
Units.
Units matter.
Okay, so let's move on.
That was hard.
All right, so this, for 3 angles and 1 unknown side, you can use this formula over here.
And you should recognize that that all is coming from combining things from the law of sines.
Okay, for 3 sides, you've done this before. You can use the law of cosines to find the angle, or you could use Heron's formula, which is the area equals the square root of the semiperimeter times the semiperimeter minus A times the semiperimeter minus B times the semiperimeter minus C. Well, the semiperimeter is A plus B plus C all divided by 2. It's half a perimeter.
That's what semi means, half. Semi-annual, half of a year. Semicircle.
So, first you're going to find, this is when you have all 3 sides. So first you're going to find the sum of the sides, the perimeter, and then you're going to divide it by 2. So you end up getting the semiperimeter is 14. So now we're going to go ahead and find K.
I have a question. Should the semiperimeter be bigger than any of the given sides?
Yes.
Yes. In fact, if it's not bigger than any of the 3 sides given, you're going to get a negative under the radical, which will not be a nice thing at all. Okay, so we're going to be very careful with that. Oops, don't want to do that. Okay.
All right. So we're going to find,
Forget making that smaller. Okay.
so K equals,
There we
it's
go.
already there.
It doesn't, yeah, it didn't make it nice. Okay.
All right, K equals the square root of the semiperimeter, so 14 times 14 minus 6, we'll go from the smallest to the biggest, times 14 minus 9 times 14 minus 13. So now we have K equals the square root of 14 times 8 times 5 times 1, which equals approximately, once I put it in my calculator, 23.664. And we don't have any units, so we don't have any units. We don't know.
Oh. Unit squared.
Okay, there's. Okay, so there we go. We're done. Yay for the area! So go to section 10.2 and do number 41, and don't forget degree mode. All right, email us. One new thing, one good question, 2 old skills. Goodbye.
Goodbye.